This is the video for Mod 9 Lesson 5, Proportions and Triangles. The goal of this section is to build on our properties with similar triangles and proportions to find more efficient ways to solve some of the problems we saw in the last section. So we're going to be using something called the side splitter theorem. Finding links using the Midsegment theorem, and then also using something called the triangle angle bisector theorem. The first two theorems are actually very similar, and they're talking about proportions and segments. So the first one is called the side splitter. So the side splitter says if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides proportionally. So what this basically means is if you have, and a lot of times we see this with overlapping triangles, if we have two segments that are parallel to each other, we're going to end up dividing those non-parallel sides proportionally, right? So if I break this apart, that basically means AM over MB is going to be the same as BN over, or CN over NB. So I can break that up into a proportion. So the second theorem is talking about kind of still side splitter, but what happens when we have multiple parallel lines. This one, same concept. So if we look at the non-parallel sides, which are basically the two transversals, they're going to be divided proportionally. So we're going to find that AB over BC is the same as DE over EF. So the first example, this would be one that typically we would do with similar triangles, but since the two sides that we're solving for, notice are the non-parallel sides, I can do what's called the side splitter. So I can say that 3 over 9 is the same as 2x plus 1 over 21. Now from here, we're just going to simply go through and solve for x. You can also do some things like if you wanted to reduce the 3/9 to 1/3 to make the problem easier, you can. But basically, we're going to go ahead and just simply cross multiply. So 9 over 2x plus 1 is equal to 3 times 21, which is 63. And then we're just going to go ahead and distribute and solve. And so when we go ahead and do that and subtract, we're going to go ahead and get 18x is equal to 54. Or when we divide, we're going to get our x value to be 3. All right, it doesn't ask us to substitute back in, but if it did ask for that other segment, you would just put it, substitute it back in. But our question was just asking for x. The next example is using the version of the side splitter, but again, the same concept. We're basically looking for pieces that are proportional. So we can see here that we have an 8. If I put the whole thing together, I would get a 20. And we're really just matching up proportional pieces. So I can say that 8 over the whole thing, 20, is going to be the same as 10 over 2x plus 11. So again, what that's saying is if it's divided by parallel lines, it's making these proportional segments. So now we're going to go ahead and cross multiply. So 8 times 2x plus 11 is equal to 200. We're going to distribute. And then subtract and solve. This gives us 112. And then when we divide, we're going to get our answer of x is equal to 7. In the next topic, we're going to be looking at midsegment and the triangle angle bisector theorem. So the midsegment theorem is actually very similar to how we would solve with similar triangles. So what this says is if you have a segment that's joined by two midpoints, and we can see that by the congruency marks here, what that means is that first of all, the third side and the midsegment is actually GH, just so we kind of, when you're looking at it, when we say midsegment, we're talking about that segment that's connecting the two midpoints. That first of all, we're going to have that it's going to be parallel to the third side, and it's also going to be half the length. So for example, if DF was 10, GH would be 5. So we're going to see an example of a problem like that in a little bit, but a midsegment has that 1 to 2 relationship, and if we ever forget, let's say these are both 1 and this was 2, if you did similar triangles, you would be able to solve it. You would still get a 1 to 2. The triangle angle bisector theorem is if you have a ray bisecting an angle of a triangle, then it divides the opposite side into two segments where the ratio between the segments is the same as the ratio of the sides. So what that means is that these two sides are going to be the same ratio as UV over VW. So it really is just, again, kind of a proportionality that we're using, that it's dividing it, and you're going to get that same ratio. The first example we're looking at here is talking about a midsegment, and even if it doesn't tell us midsegment, we can see that SR is formed by these S and R, which are two midpoints, right, because of those tick marks. So what's happening is we know that whatever SR is, it's going to be half of GE. So it's like a 1 to 2 relationship. So like, again, if I forget, if I call these both 1 and this is 2, it's like using similar triangles to solve. So I know that 1/2 is going to be the same as 2x minus 18 over 2x minus 12. Because that SR is going to be half of GE. So it's, again, it's just using that relationship. I can then cross multiply. And just solve for x. I'm going to subtract 2x from both sides. And so we'll get 2x equals 24, or x is equal to 12. The question was asking for SR. So if I get SR to be, or x is 12, when I substitute that back in, I'm going to get 2 times 12 minus 18. And that's going to end up giving me, just so happens to also be 6. So that means SR would be 6, and actually GE would just be 12, because that'd be half of it, or twice it. In the last example, this again is angle bisector, because we can see that it's cutting that angle in half. So again, what that's doing is it's dividing this triangle proportionally. So what that means is if I, let's say, write x minus 1 over 10, that's going to be the same as 15 over 25. So notice parts from the same half of the triangle are kind of lined up either on the top or the bottom. And then I can go through and cross multiply. So when we go ahead and multiply that out, I'm going to get here 25, x minus 1 equals 150. I'm going to add 25 to both sides. And then we're going to get our x value for this to be 7. So x is equal to 7. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.